In this tutorial we are going to talk about thermal energy, and energy is the ability or the potential that the body has in order to perform a work. And we have two kinds of energies. The first one is content energy. It's contained in a body, and this is, for instance, any potential energy, which can be the potential gravitational, which can be the potential elastic. It has also the kinetic energy, and the kinetic energy, for instance, is 1/2 of mass velocity squared. And right now in thermal energy we are going to include one energy, which is, for instance, the internal energy. And this internal energy is the sum of all the microscopic energies in the body. For instance, energy is made of atoms, and the atoms are moving and rolling and whatever. They are having energy. The sum of all of these is going to be, for instance, called the internal energy. Another kind of energy is, for instance, the transit energy. It's the energy that is going to move from one body to another. And the first kind of energy that is performed by interactions is, for instance, work, which we know the driving force is going to be, for instance, a change in pressure or a change in voltage if we are talking about electrical energy. And then we have, for instance, heat, which the driving force is going to be a change in temperature. The Zeroth law of thermodynamics stated that if we have two bodies, then if they have the same temperature, then there is not going to happen anything. Everything is in thermal equilibrium. But if we have two bodies which the temperature is different, then heat is going to start to flow. And then again, these heats, well, the Zeroth law will state that they come into thermal equilibrium. And we state the thermal equilibrium as a temperature where if body 1 starts to drive heat, or there is a flow of heat towards the second one, then the heat that is going to be exchanged is going to be the same. So the sum of heats at the very end has to be equal to 0. This will state that the heat which is gained by a body is going to be equal to minus the heat that is going to be lost by the other. So this exchange states that whenever one gains, the other one loses. Heat is measured in, for instance, calories, and 1 calorie is 1.86 joules. BTU, which is the British thermal unit, and is 1055 joules. And for instance, kilowatt hour, which is not power, is actually energy, 3.6 times 10 to the 6 joules. In a later tutorial we're going to explain more about how the calorie was generated, and the other two, for instance, BTU is for English system, and kilowatt hour is something that we use usually in life.